Today we are investigating number patterns. We're going to look at just how amazing the mathematics in those number patterns are. Throughout today's lesson, I want you to be asking yourself a couple questions. What can we predict about the next number in the pattern? And how can we justify our answer? Here's a pattern made up of 4 expressions so far. What patterns do you see in the expressions below? Well, starting with the very first number, it goes from 1 to 1, 2 to 1, 2, 3. So as the pattern goes on, you gain a digit in that first number, and that is increasing from 1. The 8 stays the same. So that first number is always going to be multiplied by 8. And the number being added increases by 1 number each time. Okay. Now I want you to use a calculator to calculate the value of each expression and tell me, what pattern do you see? So in red, you'll see the values of the expressions. Each time you move forward in the pattern, the value gains a digit. That digit is decreasing from 9. So from 9 to 9.8 to 9.87, and so forth. So using what we just talked about in the patterns that we saw in both the expression and the value, what do you think the next expression in value will be? And here it is. Sometimes patterns are not created with addition and multiplication, but with the numbers themselves. For example, when the fractions in this sequence are changed to decimals, an interesting pattern develops. So I want you to use your calculator to change each of these fractions to a decimal. Remember, when you see the fraction bar, that means division. So you're going to take on your calculator 1 divided by 9 to change 1/9 into a decimal. And this is what you should get. So it's the numerator continuing on your calculator. So 1/9 would have been 0.11111 and so forth. So these are all repeating decimals. Repeating decimals are called repeating decimals because they repeat indefinitely. So instead of using the ... like what I showed you in the last slide, we are going to use a bar over the digit that repeats. That's called a vinculum. So you could write 1/9 as 0.1 with a bar above the 1. You could write 2/9 as 0.2, the bar over the 2. Those were all repeating decimals. I want you to list the next 5 fractions in this sequence and predict how they would look as if they were written as decimals. After you predict, then go ahead and try it on your calculator to confirm. And this is what you would have gotten. 5/9 would be 0.5 repeating. So we write that as 0.5 with a vinculum, that line above. So my question to you is, what did you do when you got to 9/9? Did you continue the pattern and put 0.9 with a vinculum? Or did you, in your mind, say, well, 9/9 is 1 whole? So then my question to you is, are they equal? Okay, we're going to dive into this a little bit in class, but if you want to do a little research before I see you next, feel free, because this is kind of an interesting thing to think about. Decimals that have only a finite number of digits are called terminating decimals. Some fractions can be written as terminating decimals like below. 1/2 can be written as 0.5. There's nothing after the 5, and there's no vinculum above the 5. That means this is a terminating decimal. 1/2 written as a decimal terminates. 3/4 also terminates because 3/4 is equivalent to 0.75, 75th hundredths. There is no vinculum above either of those digits, and there's nothing after the 5. Those terminate. So let's practice. Does the decimal equivalent of this fraction terminate or repeat? 5/6 is a repeating decimal because it is 0.83 and the 3 has a vinculum over it, meaning it would go on indefinitely. Is 2/5 a terminating or repeating decimal? It is a terminating decimal because 0.4 terminates. Nothing after the 4, no vinculum. All right, that's all I got.